everyone, this is Lesson 1-2, Analyzing Graphs as Functions and Relations. Our learning target for today is for students to be able to use graphs of functions to estimate function values and find domains, ranges, y-intercepts, and zeros of functions. This video will specifically focus on finding the y-intercepts of a function. In example 3, we are finding the y-intercept. In part A, we're going to use the graph of the function f of x equals x squared minus 4x plus 4 to approximate its y-intercept, then find the y-intercept algebraically. Okay, so the y-intercept of a function is where the graph crosses the y-axis or intersects the y-axis. So based upon this graph, this point right here is where the graph of the parabola crosses the y-axis. So if I estimate what that y value is, I'm going to assume my scale is 1 here, and we're going to say that the y-intercept is 4. So the y-intercept is also when the x-coordinate is equal to 0, right? The ordered pair for this point would be 0, 4. X is 0 and y is 4. And that is always true. When you cross the y-axis, your x-coordinate at that point is 0. So when they ask us to find the y-intercept algebraically, right here is my estimate from the graph. When they ask us to find the y-intercept algebraically, we want to find f of 0. We evaluate the function at x equals 0, so I'm replacing x here with 0, and I'm going to take 0 squared minus 4 times 0 plus 4. I'm going to evaluate my function at x equals 0. So if I take this x and replace it with 0, all these x's also get replaced with 0. And when I do that, 0 squared is 0. Negative 4 times 0 is also 0, so I get 0 minus 0, and then at the very end I get a plus 4. So 0 minus 0 is 0, plus 4 gives me 4. So algebraically, my y-intercept is positive 4. We're crossing, obviously, the y-axis right here at y equals 4. And algebraically, by what we have solved here, or when we evaluated the function at x equals 0, we also got a y-intercept of 4, confirming our estimate from the graph. In example 3, finding the y-intercept, part B, we use the graph of a function g of x equals, right here, this is the absolute value of x plus 2 minus 3, to approximate its y-intercept. Then we are going to find the y-intercept algebraically. So looking at the graph, here is our y-axis, our vertical axis, and the graph of g of x, which is graphed in blue here, is going to cross the y-axis what looks like y equals negative 1. Okay, the ordered pair for this point would be, again, x is always 0 for the y-intercept, and our y-coordinate then is negative 1. Now, to confirm this algebraically, we are going to evaluate g of 0, because we said that whenever we're finding the y-intercept, the x-coordinate is 0. So we'll find g of 0 in this case, and take the absolute value of 0 plus 2, and then subtract 3. So if I treat absolute value bars just like I do parentheses in terms of order of operations, I'll simplify inside the order absolute value bars, and 0 plus 2 is 2. I get the absolute value of 2 minus 3 equals, the absolute value of 2 is 2. 2 minus 3 is equal to negative 1. Okay, remember absolute value. If you take the absolute value of any number, it's equal to the positive value of that number, or the absolute value is a number's distance from 0. By definition, and so therefore the number positive 2 is 2 units from 0 on a number line, so therefore its absolute value is 2. Okay, so just to a refresher on what absolute value means, But our y-intercept, algebraically, we figured out it was -1, and from the graph estimating, it's also -1. In example 3, check for understanding. You're going to use the graph of the function below to approximate its y-intercept, then find the y-intercept algebraically. You're given the function f of x equals x to the 4th minus 3x squared plus 2. So here's your equation. Here's the graph of that function. And you have 4 choices, A, B, C, and D. The first choice, A, lists a y-intercept of -1. Part B lists a y-intercept of 0. Part C lists a y-intercept of 1. And D lists a y-intercept of 2. And the second part of each of the answers here lists the y-intercept found algebraically. Remember that when you're finding the y-intercept, you're evaluating the function given to you for x equals 0. I would like you to work out the problem, select your answer, and press submit.